Joanne attempts 3 practice test papers in mathematics. The probability that she passes the first paper is 0.6. Whenever she gains a pass in a paper, her confidence increases, so the probability of her passing the next paper increases by 0.1. Whenever she fails a paper, the probability of her passing the next paper is 0.6. Complete the given probability tree diagram for Joanne's 3 attempts, labeling each branch with the correct probability. So, this is 0.6, and since they must add to 1, 0.4. If she gets to here, her confidence increases, so this one's 0.7, this one's 0.3. If she gets to here, this remains 0.6, and this is 0.4. If she gets to here, she's passed 2 papers. This is going to be a 0.8 and a 0.2. If she gets to here, the passing reverts to 0.6 because she just failed. This one's 0.4. Here, this one goes up to 0.7 because she just passed. This will be 0.3. When we get to here, this one's going to be 0.6 and 0.4. And the results are pass, 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 fail, pass, fail, pass, pass, fail, 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 pass, pass, fail, pass, fail, 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 pass, and fail, fail, fail. Calculate the probability that Joanne passes at least 2 of the papers she attempts. And that means 2 or 3, at least 2. So the ones we want are here, 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 and here. So that probability is going to be 0.6 times 0.7 times 0.8. That's going straight along the top of the diagram up here. And then we're going to add that to. So we need to get to here on the diagram, which is 0.6 times 0.7 times 0.2. And then the next one is going to be 0.6 times 0.3 times 0.6. And finally, we're going to have 0.4 times 0.6 times 0.7, and we just need to calculate. And that gives us 0.696. Find the probability that Joanne passes her third paper, given that she passed only 1 previous paper. Okay, so that's a given. So we've got probability passes the third, given 1 previous, is equal to the probability of third and 1 previous, divided by the probability of 1 previous, which essentially, I think, is going to mean 1 of the first 2. Okay, so I'll just clean the diagram up a bit for doing this bit. So let's look at the one where the third paper is passed. We've got that one, that one, that one, and that one. But we want only the ones where we've only passed 1 of the previous papers. So we'll be talking about this one and this one. We don't want that one. We don't want that one. So for passing the ones that we want, we've got 0.6 times 0.3 times 0.6, which is this one. And then we have 0.4 times 0.6 times 0.7. And we need to calculate that. And that gives us 0.276. Now, as far as just passing one of the first two, we only need to look at the first part of the diagram. And so, passing 1 out of 2 is there or there, or it's there and there. So that is going to be 0.6 times 0.3 and 0.4 times 0.6. So that's our denominator. So we've got the 0.276, and then we've got the 0.6 times 0.3, add 0.4 times 0.6, which is 0.42, and then we just want to calculate that. And it gives me 0.657. And we could give it as a fraction instead, but I'm just going to give it there.